Right guys, so we're going to have our halogenoalkanes quiz now. So we have 10 questions on halogenoalkanes. So I advise that you have your poster with you when you're doing this quiz, and in between each question I'm going to suggest that you pause the video so that you get yourself some thinking time. Right, so question number 1 coming up. Okay, which of the following silver compounds will be yellow in color? Okay, so we use this test to identify the halogen present in a halogenoalkane. We would use silver nitrates to do this, so we might form silver bromide. If it's got a bromine in, if it's got an iodine in, we might form silver iodide, or if it's got a chlorine in, we might form silver chloride. So, which of these is going to be yellow in color? Pause the video now and have a check of your poster to see if you can find the right answer. Okay, so did you get it? The one that's going to be yellow in color will be this one. Silver iodide is yellow in color. And just to check, that one is cream colored precipitate, and silver chloride are white colored precipitates. Right, hopefully you got that one right. Question number 2 on our halogenoalkanes quiz. What is the missing organic product in this reaction? So we've got bromoethane here reacting with sodium hydroxide dissolved in water. Probably should have added here that it's under reflux as well. You're going to form sodium bromide. And what other product will you form here? So pause the video now and check on your poster, see if you can get the right answer. Okay, so hopefully you paused, you've checked, and you found out that the right answer is CH3, CH2, OH. You're going to make ethanol in this reaction. This is a nucleophilic substitution where the OH and the Br swap over. Obviously, the Br and the Na then join together as spectator ions to form sodium bromide. Right, question number 3. Okay, which of the following halogenoalkanes will react most quickly? So we want the quickest reaction here with sodium hydroxide. So in the reaction that we just saw, with sodium hydroxide in aqueous solution, refluxed up with a halogenoalkane, which of these halogenoalkanes, bromoethane, chloroethane, iodoethane, or fluoroethane, will react the most quickly with sodium hydroxide? Pause the video, check your poster, and try and find the right answer. Okay, the correct answer is C. Iodoethane will react most quickly with aqueous sodium hydroxide under reflux to swap the Na for the I. Reason being, this carbon iodine bond is the weakest of these 4 bonds. And that's because the iodine is a big atom, and so it sits a long way away from the carbon, relatively speaking. The fluorine is the smallest of these, so it's really tucked in close to the carbon, so that's the strongest bond. The chlorine is the next strongest bond. That's a little bit bigger than fluorine, and then the carbon-bromine bond is the next strongest. So the weakest bond is the carbon-iodine bond, and that's the one that's going to react the fastest. Second fastest, third fastest, slowest. Okay, question number 4 in our halogenoalkanes quiz. Can you spot the 2 errors in the following mechanism? So I've tried to show the mechanism of nucleophilic substitution here, and I've included 2 errors in there. So pause the video for a second, look at the image, and think to yourself, what 2 mistakes has he made here? Pause it now. Okay, so you've paused, you've thought, and you've come up and spotted two errors. First one, did you spot the fact that I only included a single-headed arrow here? There are two electrons moving from this carbon-bromine bond onto the bromine. We need to show the both of them with a double-headed arrow there. So that was error number one. And the second error, everything's all fine going along here. The second error is here. The bromide will leave as Br minus, not as Br plus. So error number one was in the curly arrow being a single-headed arrow here, not a double-headed arrow. And error number two, I put the wrong charge on the bromide ion. Silly me. Okay, question number 5 in our halogenoalkanes quiz. Right, now, can you put the following 3 steps into the correct order for testing for a halogenoalkane? Okay, so we've got step A, step B, and step C here. What is the correct order, sequence in which we should perform these steps in order to test which halogen you have in your halogenoalkane? Pause the video, have a think, and then try and give me a correct order here. Pause it now. Okay, so first step that we should be performing here is step C. You should take your halogenoalkane, you should react it with aqueous sodium hydroxide in order to knock off the halogen. You're basically carrying out a nucleophilic substitution there, and you're releasing the halide ion into solution so you can test for it. The next part you should be doing is A. You should then acidify the mixture to make sure you've got rid of any excess sodium hydroxide that might be hanging around from the first stage. And the acid we use to acidify is always nitric acid. And then finally, B. Add silver nitrate and you should get a precipitate. White precipitate if you had a chloride ion, a cream precipitate if you had a bromide ion, and a yellow precipitate if you had a iodide ion in your halogenoalkane. So C, A, B. Question number 6 coming up. What type of reaction is occurring here? Okay, so got myself iodoethane, got myself some sodium hydroxide, dissolved it in ethanol, and I'm refluxing it up. I'm making myself ethene, sodium iodide, and water. What type of reaction is this? Pause the video, have a think, then give me your answer. Right, did you get it? This is an example of an elimination reaction. An elimination reaction. Okay, an elimination. We've got rid of, effectively, HI. We've eliminated HI from this molecule and we've produced an alkene. Now, a good tip is when you're making an alkene, quite often you will have had to eliminate something from it in order to generate that double bond. So if you're generating an alkene, think to yourself, this is probably an elimination reaction going on here. Now, with halogenoalkanes, you're either going to get substitution, you're going to swap that iodine out for something else, or you're going to get an elimination. And it depends very much on the solvent present. And it's the ethanol here that causes elimination to happen rather than substitution. If we wanted substitution, we would have used water as our solvent. Right, question number 7. Can you complete the gaps in the following passage? Okay, there are 4 words that I'd like you to include here. See if you can include all 4 once you've had to think about it. So pause the video and I'll come up with about right answer in a second. Okay, right, so 4 words. CFCs, something something carbons. C, chloro, fluoro, carbons break down in the upper atmosphere due to exposure to. So these molecules are very, very stable, lower down in the atmosphere, but as soon as they get up to the upper atmosphere, they're exposed to ultraviolet light, and that will cause these molecules to break down, and when they do break down, they're producing free radicals, and as hopefully you know, these are extremely reactive species. And what are they going to react with? Well, there's not a great deal up there in the upper atmosphere, but there is quite a lot of O3, and that is ozone. And this process happened back in the 1980s, quite a lot, because we were using chlorofluorocarbons a lot for aerosols and air conditioning units and the like back then, and we didn't realize that they were going up to the upper atmosphere and reacting with ozone. Big hole in the ozone layer, which is not good news for us here on Earth, because ozone is our sunblock, protecting us from some of the more harmful ultraviolet rays from the sun. And as a result, skin cancer rates went through the roof in certain parts of the world. Hopefully now, though, ozone layer has repaired itself, and we've managed to rectify that error. Okay, question number 7 in our halogenoalkanes quiz. Sorry, question number 8 now, rather. Okay, so what is the name for the following mechanism? Okay, so we have OH minus here reacting with chloromethane. That's giving us methanol and a chloride ion. What is the name for the following mechanism? So pause the video now and check your poster, see if you can go up with the right answer. Okay, so you've paused and you've checked. Did you come up with nucleophilic, if I can spell it right, philic substitution? Nucleophilic substitution. So this is our nucleophile, and we're swapping the OH minus out for the Cl. So it's a substitution, it's a swap, one for the other. If we were doing this and we wanted it to happen, the solution would need to be water in order for that to happen. Otherwise, there's a danger of getting elimination, although it would be hard to get elimination with just one carbon here. Nucleophilic substitution. Right, question number 9. What solvent must be used in the following reaction? Okay, so we got potassium hydroxide with iodoethane, giving us ethene, potassium iodide, and water. We're refluxing up the mixture. What's the solvent we need for this reaction to occur? Pause the video, check your notes, and I'll come back with the right answer in a second. Okay, right, so what do we need to dissolve this in? We need to dissolve it in ethanol. Dissolve this mixture in ethanol and you will get an elimination reaction producing an alkene here. However, if you were to dissolve this in water, you would get a substitution reaction. You would have made an alcohol instead, but because we're making an alkene and we want an elimination reaction, we dissolve it in ethanol. Hopefully you got that one right. And number 10, our final quiz question on our halogenoalkanes quiz. Can you name the 2 products formed here? So we've got bromoethane. We're reacting with sodium hydroxide in ethanol, refluxing to give us A. Sodium hydroxide in water, refluxing to give us B. I want you to name product A, organic product A, and organic product B, please. Pause the video, have a think, see if you can come up with the right answer. Pause it now. Okay, right, so A, what is it going to be called? What is the name of the product in A? Well, we've got ethanol as our solvent here. That means we're going to get an elimination reaction going on. So our organic product A is going to be ethene. Going to get rid of HBr from that molecule. However, if you were to dissolve sodium hydroxide in water instead of in ethanol, then product B, we're going to get a substitution reaction, nucleophilic substitution. We're going to swap the Br for an OH, and in that case, your product is going to be ethanol. Right, so 10 questions on halogenoalkanes. Did you get 10 out of 10? If you didn't, where did you go wrong? Find out and and check your knowledge.